evening, everyone. Rob Leslie's my name. I'm the founder and the CEO of a company called Sedicii. We're based in Ireland. I met Norbert, I think, 8 or 9 years ago in Europe, and it was a complete random note, I think, on whatever day last week. So I was coming to Japan as part of an EU trade mission and said, would I pop by and give you a quick introduction to what we're doing. So I'm going to take 20-25 minutes or so, introduce you to some of the things. Some of this stuff is pretty far out there in terms of its novelty and its innovative components. But I'll just give you a quick intro to the core of our business, which is all around digital ID, KYC, know your customer, and anti-money laundering checks, but done in a collaborative context, where no single institution is doing it on its own. It's now doing it as part of a network. And it's leveraging the data that each institution has for the benefit of the whole. And you might say, how on earth are banks doing that? Because their data is extremely valuable to them, and they don't want anybody else touching it, seeing it in any way. And this is where the magic of the cryptography that we've created comes into play. So there's one economy in the world that is booming right now, and it is the criminal economy. It is growing in double digits. It's the third largest economy in the world. It's going to probably exceeded $6 trillion last year, and it shows no sign of slowing down. And this is one of the things that governments are extremely concerned about, because every yen, euro, dollar, whatever, that goes into the hands of the criminals comes from hardworking people who've been defrauded, scammed, whatever, and have lost from a few single-digit dollars to their life savings because they believed and were tricked into doing something that they will regret probably for the rest of their lives. So what we do is we help governments, banks, companies collaborate, where we can leverage the data that they all hold to derive much more insight and ultimately assess risk so that we can find who fraudsters and the criminal elements are. We do it without any sharing of any data. We do this using cryptography, things called zero-knowledge proofs, multi-party computations, and a new one that we've created called messageless computation. And these are cryptographic protocols that allow organizations to work together in a way where there's no sharing, no exposing of any data, but the data acts as if it's pooled, but it's not. And it's the foundation of what we think is going to be Web3, because you now have any organization potentially able to use the data of any other organization without actually having it, holding it, or seeing it. And you might go, how on earth do you do that? There's a bit of magic in there, but that's what I'll get into in a second. So we have a platform today that does digital onboarding for companies. We identify individuals and corporations, a little bit like databank. We have connections to registries, official authoritative government data in over 130 countries, where we're able to retrieve the actual identity of a company and who the people are behind that company. Not every country is equal. Some of you get very good data, and some of them you get rubbish data, some of you get nothing at all, because that's where they make their money, hiding that information. But whatever we can get, we get. We use a platform, a tool called business process modeling and notation that allows us to build very easily complex business processes by essentially dropping in modules into a sequence. And so that if somebody says, I want to change my business process, I just take a module out of the sequence and I drop a new one in. It's graphical, so it's very easy to make changes. There's no coding involved, which means we can deploy a change very quickly. And we now want to move this into a space where I can integrate this with other organizations. So creating collaboration between organizations so that they can share their data with all of the controls that you might want to have around that in terms of privacy and security and all of the necessary tools that make it effective and useful will all be part of the platform. An example that we're working on right now is helping banks fight money laundering and fraud. A very simple fraud that is probably costing $6 billion around the world today, is where somebody gets tricked into paying money to the person they think is legitimate, and lo and behold, when the money goes, they find that it was actually paid to a fraudster, to a bank account that had no bearing whatsoever to the individual they thought they were paying. And the solution to this is really easy. if I could ask the receiving bank, I think I'm sending money to Michael Murphy and his bank account is 12345. Does Michael Murphy really own that bank account? And if they could say yes to me or no to me, I could stop it at source, because I now know that I'm paying money to somebody who is not who they claim to be. But today, the banks can't do this. What we enable with the cryptography is the ability to query them cryptographically without seeing or touching or them having to share their data and getting a result back that says there's a 100% probability based on the question you just asked that the answer is wrong. And that's all I need to know, because I can now stop the transaction and I can stop it at source before the person has lost their money. Banks should love this because they now have extremely happy customers because you just saved them a bundle of money. A little bit about us, we're 9 years old, we have a number of patents pending and granted. We won a bundle of awards over the years for the innovation that we've been working on. Plug and Play is in there. The one I'm probably most proud of is being named by the World Economic Forum as a technology pioneer. It puts us into the class of Google and Facebook and Twitter and all of the glitterati of Silicon Valley. We've got a little bit to go and to catch up on some of those guys. At least we get to sit in the same room and shake hands with some of the CEOs of these companies, which is a bit of fun. So I'm going to talk a little bit about messageless computation. This is the new cryptographic protocol that we've created that enables the non-sharing of data that others have and you have within a net. And we think it's going to change how data is stored and processed, potentially globally. So a little bit of context. Web 1, the first iteration of the internet, when it came along, everything was centralized. And it was centralized in a way where you couldn't interact with the server that you were doing something with. It was read-only, essentially. Along came Web 2, and we now have the ability to interact. We could send information to somebody, we could receive an answer back. But still, from a storage and processing perspective, the information was still centralized. What Web 3 promises to deliver to us is a world where I can now send, store, and process information in a fully decentralized way. And what I mean by storing and processing stuff is truly being able to process data that's held on multiple servers at the same time. And I'm not talking about copying data from one place to another place and reusing it, which is what we do today. It's a kludge, and we just see a proliferation of the same data in hundreds, if not thousands of places. That's not what I'm talking about. I'm talking about leaving what data you need in one place, being able to combine that with data from other servers that other companies and other organizations own. A KYC check might be a bank has some data, the government has some data, maybe an airline has some data, a telco might have some data. I want to combine all of that to make sure that you are you, and then I'll authorize the transaction and it happens instantaneously. So multi-party computation is the cryptographic protocol that this came from. And what multi-party computation allows you to do is to process data held by different organizations in a manner where none of the organizations learn anything about the data the others have in the computation. So all of us in this room could have data. We could all contribute something. Let's say I want to calculate the average age of everybody in the room. We all input into that computation our age, and boom, out pops a result that says the average age is 25.3. Nobody in the room learns the actual age of anybody else. You just get to see the result, right? And that's useful from a privacy perspective because I can now keep my data private. I don't have to share it with anybody, but I still get to get access to the data that everybody else has. Problem with it is it's slow. When you have complex computations, they grind along. They can take minutes to hours to sometimes days to compute when they're complex. And the reason for that is that all the nodes have to talk to each other. They're not sharing data, but they're communicating. And they have to communicate in a sequence. Every communication takes 200 milliseconds, a network interaction, essentially. So multiply that by millions and millions, and you can see why it takes a long time. Our innovation is that we've eliminated the need for all of that communication. Essentially, what was happening between all of the different nodes in the computation is now happening inside a microprocessor. So it's executing at CPU speeds. So it's gigaflops rather than 200 milliseconds per interaction. And what this means is you get an improvement in speed of anything from 1 million to 1 billion times faster, which makes computations that were previously non-feasible feasible. Another thing that it solves is this, what's known as the blockchain dilemma. Essentially, the goal for blockchain is to try and achieve growth of all of these three vertices at the same time. I want to have greater decentralization without compromising my security and being able to scale really quickly. Generally what happens is you can have two and the other one sort of falls away. So I can have better decentralization and more scalability, but I suffer on the security side. We think we've solved this problem as well, so that you get this balloon effect where the three vertices expand together. I'm not going to spend a lot of time on this, but the method of doing this, essentially, like all great inventions, came from putting two pieces of currently existing cryptographs together, rather than just using one. We took the best parts of both, combined them, and suddenly realized, wow, if we put these together, we can actually make this whole thing much, much faster. And it's got applications in all of these different areas. Encryption, a databank for the metaverse, so that we now have the ability to store information in a completely decentralized. So an example of old SMPC, so I take my private key. If anybody here has crypto, and if you do, you know that your private key is the magic key to the kingdom. If anybody steals your key, they're going to potentially steal your crypto, and you're going to lose whatever is there. What SMP allows you to do is to take your key and break it into pieces and store each of those pieces on a node, on a different node, so that I can still process a transaction by signing it with my key, by running a computation that takes each piece from each node, combines them to sign a transaction to say, this is me, I'm authorizing whatever needs to happen. It's slow, but it's sufficiently fast for the world that we live in today. What we've done is we've made it really fast so that you can execute this at scale for lots of transactions and combine it with other things. So, for example, if I wanted to move Bitcoin from my wallet to Ethereum and I wanted to put something in Solana, I could sign a multi-party computation with 3 keys, all distributed across the network at the same time, with one master key, if I wanted to do that. Yet, no single organization has access to the entirety of that information. I'm the only person who can do that because I have the magic fingerprint or facial biometric or whatever it is I determine is critical to the authentication process within that. A very simple example that I use to explain what multi-party computation is a very simple thing like a credit card payment. So today on Netflix or Amazon, when you want to buy something, typically most people will have a credit card stored on file. That credit card will be encrypted, but it will be stored on a single central server. That credit card information being broken into, say, 10 pieces, a little bit like a jigsaw puzzle. And I store each piece on a different server. I can still process my credit card payments without ever recombining each of those pieces from my jigsaw puzzle together. So nobody ever sees my credit card information ever again. And what this does from a cybersecurity perspective, it completely changes the risk profile of the data. Because now a hacker has got to steal data from 10 different places rather than one. And the data itself has been transformed into something that is non-readable. It doesn't make any sense unless you can reverse it, and that's almost impossible. I'll explain why. We use a mathematical transformation process when we to turn it into something that's known as information theoretic secure. And information theoretic secure is a one-way mathematical transformation that you apply to a piece of information that turns it into something that might be hidden in a vault to the equivalent of ash. How do you take a pile of ash and reverse it so that you get the information back? You can't. It's impossible. And that's what we do mathematically to the data. You can't reverse it. yet it still has meaning to the cryptographic algorithm that needs to process it. It's really clever. So we come back to the speed of this. We've now figured out how to scale this and how to do it really fast. So information theoretic security on the bottom right. We've got speed and scalability up to 1 million or 1 billion times faster on the other side. And from a decentralization standpoint, we now have a network. Let's say we've got 1 million nodes in this network, where I could have thousands and thousands of transactions happening in parallel that all use randomly different nodes in the network. They're not queued like the Bitcoin blockchain. It's not sequential. They can all run in parallel. If I wanted to write something out to a blockchain, like Ethereum or Bitcoin, as a proof that I did something, I absolutely can do that. But that's not what we're aiming to do. What we're trying to do is to get decentralized storage and processing running at scale that's highly secure. And if we want to add in sequential sort of proof that something happened at a point in time, we can write it to a blockchain somewhere and we get that proof that it happened on this date, at this time, the evidence is there. What does this mean for crypto and for others? So we're thinking about storing keys or any other cryptographic evidence that you may not want to put in one place. You can now shred it and store it in this network. You know where it is. It's sitting in 1 million haystacks, and you know which ones, but nobody else does. So if someone wants to come and steal your magic NFTs, they're going to have a really hard time trying to do it. Private key storage, decentralized signing, and I'm talking about biometrically enabled documents. For years I've been aghast at how we sign documents digitally. I send you an email and I drop an image into that is the equivalent of me signing something. I've signed documents for other people. I shouldn't admit that, but I have. Why? Because they told me, get into my email, download the document, and I put a squiggle in it, and everyone believes that it's real. There's no legal binding to the person. Now, you could sign a document with your face or your finger, or a combination of your face, your finger, device, location, time, all of these different things very easily. That will absolutely link it to you, and only you. Nobody else can impersonate. Authentication. Passwords. What if we could store passwords in a network where they were fragmented so that nobody could actually steal them? Hallelujah. That's where we started, actually. That's where Norbert and I first met, was using zero-knowledge proofs as a mechanism to improve how password authentication worked, so that you didn't have to share your password in the act of authenticating. As an interoperability layer for all the different chains. What if you could, again, create computations that allowed you to interact with Bitcoin, Ethereum, Solana, whatever, all at the same time? That'd be hugely useful, because today anybody who's traded crypto knows how clunky the whole interface is. It's awful. And if it's going to become mainstream, I don't think Bitcoin maybe is going to be mainstream, but there will be tokenized implementations that will take all of that nice tech and apply it to real-world finance to do different things. Why? Because it's efficient and fast and cheap. But these interfaces have got to get fixed. Talked about multi-chain wallets, DAO tools. I'm not going to get into all the detail here, but private metadata, interoperable data, scaling, private smart contracts, and the list goes on and on and on. There's tons of things in here that we think that the technology could be applied to that makes them more scalable, more secure, and more decentralized, more robust, because it's got embedded redundancy and all these nice things in it. It's not just about crypto. We think potentially you can apply this to billion-dollar industries that exist out there today and make them safer. Talked about distributed storage of passwords. So, taking a LastPass, or 1Password, whatever it is, where you've got millions of passwords all stored on a single central server. God, that's terrifying. The damage that would do if somebody was able to hack into that and steal all that information. And it's one password probably away from happening. But if the information was distributed, where no single piece of information was on a single server, it was distributed across a very broad network, you could eliminate that. One that we've had a lot of inquiries about is healthcare and drug discovery. Being able to process DNA, for example. Legally, you're not allowed to send DNA outside the lab that holds it in many countries. But if I could run a multi-party computation processing this data in a manner where the data stays where it is in each of the labs, I would be able to do a ton of new research on cancer drugs that potentially now access all of this type of data. And there's a bunch more. Governments, we know how inefficient governments are. Government departments don't communicate well. But again, you could now build technology that would allow access to government department data without them having to share or expose that data to anybody else. So they can still have their walled garden and their siloed data, but I'm still able to extract the efficiencies that I want as a citizen from them. We want to build, or rather Nillion wants to build, Nillion is the company that we've licensed the core technology to, an ecosystem where developers are able to take the tools that will be built for them to create their own applications. They could be on the crypto side, they could be on the real world business side, doing a whole range of different things in any vertical that potentially becomes useful. And you've got all of the wallet stuff, smart contracts, the metaverse, then in the business world, you've got biometrics, I think, is a really interesting one. Governments around the world are terrified, again, of biometric data being stolen. But if I could take my facial template, for example, and break it into 10 components and store them on 10 random servers in the United States or in Europe or in China, wherever the government determines is appropriate, that is a much more secure way of storing that data. So it eliminates, I won't say eliminates, it massively reduces the risk. By building consent on top of that, somebody wants to use that template and they need my permission to do it, I can do that. So I can walk into a baseball game or football match, whatever. Camera recognizes me and I've given it advance permission to process me, so I don't have to take out my ticket and stick it in the machine. My face is my ticket and I just walk in. But it only happens with my consent. So it touches everything, businesses, governments, consumers. And what we're trying to do with Nillion is to create this buzz in the community where the developer world starts to see the possibility by taking what really is building block technology that nobody really wants to dive into the maths and understand what's going on. It is plumbing, right? Can anybody see the plumbing in here? Nobody can. It's in the walls. But we know it's there because the water comes out of the tap. Ultimately, it's what we're trying to create, is the plumbing for Web3 where data can move through the ecosystem and people can build tools to use that data to create really powerful applications that are going to make a difference to people's lives. So I hope that was useful. Happy to take any questions that people might have.